I just did actually. Well, I did. I tested. I tested. It's good. Heck yes. Number two, it's just, yep, a simple stainless steel shaft. I mean, if you want, you can, if you're looking for more like portfolio items, you can recreate these as a drawing if you know, take it. I'm just not requiring it for an assignment, but it doesn't mean you can't. Looks like I've chosen a front view with a section and a side and a right side view at just sections. So I'm going to draw this in its profile form on the right side view, just like the section view here, because you know I like to use the revolve command when it's a shaft. So I'm just going to draw half this profile and then revolve it around an axis there. This is the way I'm going to proceed on this one. So I've got a 5 inch by overall diameter of 2 inch, so 5 inch by 2 shaft with this kind of weird profile. So I do have my PDF opened up for this one. Well, not there. I'm going to open it with my web browser. I got to fix Adobe. Adobe's weird for me. Also operator error, but so I'll pull this up on my other screen, just draw this little profile, 2 1/8 comes down. I think it comes down a quarter, although it comes down. I'll dimension it this way. You can see my dimensions are kind of driving from the datums that we've established. But so if I just look at the profile, we can worry about datums in just a minute or look at them a little bit now. Datum here, so this is one that we haven't applied yet to a drawing, but if I recognize what this is saying is this datum is right in line with the dimension. So the dimension on this 2 inch, I'm applying my GD&T symbol right to that. So that means this is specifying an axis type datum here. So datum A is the axis through the part this way. And if, of course, if the GD&T for it was slightly off here, then it wouldn't apply to the axis necessarily. So those small changes in where I put my feature control frame differentiate between surfaces and axis or planes. So yeah. And then B would just be this left side surface, essentially, the front largest yeah, surface that I'm holding perpendicular to the datum, the axis of the datum there. Yeah, of datum A by 5 thousandths, 10 thousandths there. And I'm just controlling a hole from all that. So I think really the real, you know, yeah. Oh, and this is cylindrical. So this is a cylindricity form control on datum A. You know what I sit here and think about is cylindricity, like axis driven. It is diameter here, so I think I'm looking at a cylindricity of a diameter through here. If there was no diameter here, I think I'm expressing cylindricity of the outside surface through the part potentially. I'd have to look that up, but it makes me wonder. You know, definitely with the diameter sign and the tolerance on datum A, I'm looking at an axis type tolerance control. So okay. It's just me seeing if there's some errors here that I got to kind of watch out, but nothing stands out to me like it did on that last sheet here. But okay, let's draw this. I'll throw this over on my other screen. New part, new standard part. These are all in inches. Just make sure. Yeah, I was in English, so that's funny that I didn't know that last time I used whole command was in metric, and so it displays that. It's kind of interesting to me. So I'm going to go right side surface for my actual sketch. So there's my right side surface, which is just me selecting. This is actually this surface. Right side surface is here. So I'm gonna draw on the right side, which ends up being not the XY plane, but the YZ plane. Um, if I want to control this a little more from the get-go, I'm going to maybe I could just project some geometry here. So I could just sketch this out and then use like geometric constraints to like throw it where I want it to. Maybe I can plan it out a little bit more here and say I'm going to at least use this origin axis in this way, which is the Z axis. I'm going to use it to let's see here, constrain all my parts too. So I could project that axis here. If this helps a little bit, it's right there. That's the z-axis projection. Maybe I don't need it to be a solid line. You could use it as part of your sketch though, but I think I'll still draw a full solid, meaning that I'm just going to use lines, but now I'm going to be able to just snap them to here because that's my axis. So I'm only going to come up here. This is 1 inch because it's 2 inches overall. And so maybe I'll draw this with my dimensional inputs and I'll have to redimension it later. So this is that's 1 inch that I'm horizontal or perpendicular this way, 2.125. That's 2 1/8. And then I've got to figure out how far this comes down. So this is 1 inch. It's really up 3/4 from there on my dimensioning on my drawing, 3/4 from the center axis. So this is actually, I'm going to go perpendicular. 0.25 is the length I'm going to draw it. That's not perpendicular. Back that up. There we go. Make sure I got my perpendicular constraint showing 0.2. Otherwise, I'll have to reconstrain it, which is okay too. And then what do we cross this way? 2 inch, 2. And then back up again, the same. I don't think it doesn't. Yeah, these are on the same plane here. So the overall size from left to right of this part are the same, 2 inch in diameter. So there's 0.25 inches. And then this way I finish off at, I have a reference dimension on my drawing, 0.875, which I don't like watch. I'll put that in there just so I have it drawn at the right. I'll probably come back and delete that one and put in the overall size as the more controller than this one. Even in my sketch, I'll kind of drive it by the way I want it, the priority that I kind of have if I understand the part. So I don't know why that just ended my, I want to hook there. I'm going to go clear back to my start. Okay. So I've just worked, so it's kind of naturally constrained for me a little bit here because I've just worked from some projected geometry. It just doesn't know where it lives, like left and right, right? This doesn't know where it lives. So I'm just gonna apply. Oh, I told you one thing I was gonna do is I'm gonna dimension this out from here to here. This is what I want to be 5 on my drawing, which it is, I understand, but this is now going to become the driven dimension in a reference dimension. And technically I'd like this one to be the driven dimension. So what I can do I can delete this one. Or actually, I think this is something you can do too, because you can manipulate which one is driven and which one is drive, kind of. So this one is reference, which is what I refer to as a driven dimension. It means it's one that you don't need to apply if other dimensions are already constraining it. So if I select on here, I can push it to a. So this is just me right clicking on the dimension, and I can change it to a driven dimension. And then this one, I don't know if I can change. Yeah, it's marked as a driven dimension. I think I can unselect this and change it. I don't know if I can change them to a drive as easily though. I was wondering that. It allows you to push them to a driven, but maybe I'd have to delete it and reapply it. At least that's my go-to right now. And now I'm applying this one as the drive. Oh, it's actually is. Oh, I don't know what it did. I didn't. Why did this one not say driven? Okay, there's driven. And then driver is going to be this one. And I'll just make sure I'm going to enter it in there as 5. There we go. It really didn't constrain anything this way. All it did is kind of just change this more, this makes my sketch more correctly. And I could even like change this one and say, I knew I drew this originally there, but maybe that's not the dimension I'm going to ever use to manipulate this. Really, I like this dimension better from here to here. That's 0.75. Only because that's really from a datum control there. So I'm kind of patterning my sketch after what I would expect to get if I ever had to if I was looking at the drawing and I decide there's some things wrong, got to make some revisions. When I jump into the sketch, it's going to resemble pretty close to what my drawing looks like. So it's not going to be this other whole curveball that I've got to like diagnose and figure out what to drive where. I'm kind of systematically building this so that it's easy to modify, kind of driving by the same constraints that my drawing kind of shows, and so that's why I've chosen this. It's really just particulars. All I'm looking at is the particulars of this, and all I need to do now to lock it in is just put it where it goes, left to right, which really doesn't matter so much. But I'm going to pick center of part. It's going to be the horizontal constraint for me, but I'm looking for the midpoint of this line here. And one other thing I'll repeat because maybe we don't use this a lot either is when you have, yeah, like here I have the projected So I have multiple lines on top of multiple lines, right? And if you can't find the one you're looking for, you could you just right click and do the select other, right? Select other. Anything that's overlapping, and you kind of have to be careful because if you move off this, I think it goes away. So once you if you find a in a sketch, if you've got overlapping lines and they're hard to pick the one, right click and go select other, bring up this little it'll this little drop down will be anything that kind of lives on top of itself, and you can locally select which one you want to. So I use this quite a bit when I have geometry over geometry here to potentially, pick the one I'm looking for. Really, what I'm looking for is a midpoint somewhere here. It's that one. I can tell that this is the midpoint of my line because it's not the end point of that line, and it's not the midpoint of that line either. So this one I feel pretty safe. This grip that's showing up is my midpoint of the line I'm looking for, and I want to align it with this there. That's all it took to constrain mine. Just tell it where it lives left to right, driven by pretty much dimension, uh, finished part dimensions. Say finish. I think you can bring these dimensions into your drawing as well, actually. I think you can bring in sketch dimensions. I have to check that for sure, but I think I have experimented with that a little bit to where when you want to retrieve model annotations, I think you can pull in sketch dimensions. So if you're sketching like you want it to be drawn, that's another thing that can speed up the drawing time. Let's finish it. We could check that though. I'm not going to, maybe I will at the end of this video just see if I pull we don't need to do a drawing on this, but maybe I will just play with that concept. Can I bring in sketch dimensions and retrieve those? It's a question. This is a finished profile, so my finished sketch, revolve that sucker around this axis, which is the Z axis. That looks correct. It does have some chamfers on it, so I'll go ahead and put those in. Each kind of hard edge here, there's 4 edges here. Each one has a 0.03 chamfer by 45, so it's a symmetrical chamfer, 0.3 by 0.3. So we'll do a chamfer there. Chamfer, I just need the distance to be just pretty small, 0.03. That's about a 32nd chamfer. Of course, that's kind of measured like a welding leg length is what I think of when I see that. Distance, equal distance, edges, I need this one. So I can do a bunch of edge sets. So I don't have to do multiple. I can't remember if I can do multiple edge sets with different chamfers. Generally, my models, I don't. It kind of goes back to what we were doing yesterday. I can't remember what it was, but I was wondering if I could lump a few different sizes of a feature together. And usually if they're different sizes, I will probably do another step in my model process. But if I can bundle them and they're all the same, I'll say, okay. Yeah. Yeah. And now the last thing I need to do is put a hole in this thing and then start defining it. But the hole, let's see. So the hole to me is going to be definitely from like 12 o'clock down through 6 o'clock. If I'm looking at the front view like this, and it's going to come down through or maybe up and through, but either way, down through this way. I don't want to do it this way. I don't want to do it from 9 to 3 o'clock, essentially, right? I want to do it from this way. So it doesn't matter to me if I'm going to orient this correctly and have it show up on my drawing right. I have a center plane in here that's at that position. I'm going to draw this sketch on this center plane, and I'm just going to so I'm going to draw a center driven sketch here. Because I'm going to use this plane to draw on, which is an origin plane actually. If we don't have one there, then you could establish a new work plane to put this in. You could establish a new work plane that was tangent to this surface, and we've done that a couple times where I decide to say I don't have an origin plane that works for me well. Let me just establish a plane to sketch on. But you can also establish just a face. It's just so this is really I need to draw this way down through. So if I need to draw on a curved surface, I would establish a plane that was perpendicular to probably this plane here, but it might be on this edge here. So we've done a little bit of that. I hope to do more of that as we do a more progressive project where I'm building a part off a part, and now I'm way off the origin, and I really can't just use the origin planes to do what I need to do within a part because I'm building an assembly and this particular part is way away from the origin. So then I can just establish within its own part planes to work from, And when I do that kind of stuff, I might establish center planes on parts still, rather than have a surface plane. But because this is the one I want to use to do this sketch right there. So it's my XZ plane. I'm going to say do a new sketch here. So it orients it this way, but I can flip this around. I'm just going to do a sketch here. It shows that I'm on my top, which is good. To cut through to where I'm drawing is F7, right? Slice graphics. So now I'm looking, this is actually where I'm drawing in this part right here. And we just want to know this hole, this circle is going to live here somewhere. Here's my hole size. It's 0.375. So I'm just drawing it in real quick. And now I just need to locate it. I think that's it. So this is going to live somewhere. Well, I'm just going to constrain it to some projected geometry down the middle. So I'm going to say project. I can either choose this plane to project, which this plane looks like a line in this view, or I could choose this axis here that's going to be the Z axis as well. So either one, they're kind of doing the same thing. I might choose the axis here. There's my projected axis. Oh yeah, it's the Z axis, and if you have yours part oriented like mine does. But I just kind of like scroll through, like if I'm looking to do more projected geometry, it's pretty common for me to just hover over them to determine which one I want. But I feel like you could choose a plane here, this plane, or this axis here. And then I'm just going to coincident constrain the center of that to that axis. Usually I turn these to, this isn't going to come, this is going to break. This is what I've said over and over again. I like to turn these to construction lines when it's going to like divide my geometry. I'm going to use this as a cut, extrusion cut through. And so I really don't want this line to subdivide my circle, so I can just turn that to construction. Then this will be recognized as the profile, not two semicircles. Small deal, but I just sometimes pay attention to that. And then I just need to look. So this is like bound by this. I can't get it off that now, but I need to locate it along the Z axis here, which it has from a datum from this end here is 0.5 over to where that's located. So I'm going to go ahead and project the end of this right there. I can just select this. This will become a line. This is the end surface, right? It becomes a line like that in a projection. I've almost questioned in modern day teaching, should you start with Inventor? Because it's so funny. You can tell Inventor is kind of based kind of like off of datums, origin planes. It's so much more obvious to me. It's tricky in its own right, but I almost wonder, could someone learn Inventor first and then go back and like, let's learn CAD secondary and be like, now it's more manual and but you'd almost build like concepts that you use in CAD and orthographic. It would be interesting for me to test that out one. If I ever did a you wouldn't, and you wouldn't want to come up with the concept that it's useless, but I feel like your CAD would be easier because you're like, oh, I remember like I can kind of see how parts are constrained and controlled and parametric in Inventor easier than I can in CAD maybe. So I've kind of sat here and wondered, should I use, a more modern one first and then back teach an old one and be like, hey, let's go back in time and learn how it used to be done and look how painful it is. But I'm just because it is. Yeah, it's still important because yeah, CAD is still a lifeblood of a lot of companies. So if you're going to work for ISU, sounds like there's, and they're not alone in that. There's others. This is 0.5. So there that's located. Good. Finish this off. And now it's buried in there, but I can, some people will turn this to hidden or whatever, but I just know that my sketch is in there. So if I go to extrude, actually it just picks it because that's the only thing that's available. So if I have multiple ones, I might have to just hover over them and look for that profile. But you can turn them to 2D if you want. You can turn the visual view off to a different. I just want to do this through all. It's a cut through all. Both sides. Oh, I have to go both directions through all though, right? Like this. And then I'm going to say okay. And then just call this thing stainless steel, right? It's just stainless steel. So if I just S this down, let's see, stainless steel. I didn't call out any specific, but these are like that aluminum was 6061. That's definitely a type of aluminum. So is 440 or austenitics. I'm just looking for just stainless steel, which is just kind of a generic stainless steel. There are a lot of different stainless steels just because sometimes we need stuff that's more machinable but not very weldable. That's a concept here. This potentially this part doesn't have any welding done on it. Maybe this is all just machined. There is easier stainless. Stainless kind of is hard. The chromium and the nickel in it can be a little harder on tooling than just mild steel. And so they make a version of stainless steel that's generally unweldable, but it's easier machinable, and it still has the kind of what we're looking for with stainless generally is some kind of corrosive protection against like waters in one or acids. But there's even better stainless steels for if you have an acid that's going to attack this thing. They have like increased nickel and chromium contents to help be more resistant to acids. So uh, if I just say one of the most common like generic stainless steels is like a 304. So if you ever see a 304 stainless, I call it the run-of-the-mill stainless. Like it's all over food processing land work. Uh, and it's just that first, and it's readily available on the shelf. 304 stainless, super common, but it's not the most corrosive resistance, and it's not the most easily machinable type either. So there are like 303 stainless is what I'm thinking of, that this part could be made out of 303 stainless, which I think has a little more sulfur in it, which makes it easier machinability, but not weldable. And so anyway, it's just interesting. Your material science is super interesting. Uh, Thanks, chemists, for figuring all this stuff out. Common for me to use was we would use 303, we would use 304, we would use 316. 316 is the one that's more corrosive resistance to acids or other chemical. And so, yeah. Okay, this is done. This is just generic stainless steel. Let's just define the datums on this thing. So I need a datum axis here. So let's see. Geez, I don't know. I can't remember doing this one. Do I have any issues doing this? If I pick my datum axis, unknown feature, is it going to allow me to pick an axis? I'm just picking there. I could pick anywhere on the shaft potentially. It's a shaft. It's going to be a feature priority or feature size, just feature priority. I think I could have selected any surface here. Let me check and see what this comes up with. Oh yeah, cylindricity just seems to be its default control here. And there's my actual diameter. Maybe I'll change this to the data mate. Maybe I'll call out this surface. Only because it'll have the diameter that's associated with my real control. See, if I chose that one, it's going to show 1.5 inches above me on my geometric control. Really, if I'm looking at my drawing, I really want this geometric control to be associated with a 2-inch diameter. So I feel like that's why I'm going to make a new selection here. And yeah, then I have 2 inch. Yeah, so technically you're kind of calling out the same axis of these two parts, but and right now this isn't clear. Am I surface like am I surface control, feature control, or am I axis control? And it's not clear yet. It's definitely a cylindricity control that I'm establishing, and it's datum A, and it's 2 inch in diameter. So I like this. It's just that I need to get in here and specify the controls a little more clear. So the options I would have here would just either be circularity, straightness, or cylindricity. Okay, there's where straightness finally appears to me on this shaft, actually. And if I selected this without a diameter, we would be considering the surface. But I want it to be cylindricity, and I want it to be right here. I need this to be a diameter sign in front of it. So can I add that? Hmm. Good question, right? Let me see what else I've got. Let me focus on the dimension real quick before I move on to the look at my parts here. I need to establish a diameter here, and I also need to make this a deviation unidirectional tolerance here. So I'll adjust that at least. Let's get in here and say, oh, this I want to say is a deviation. And this, I want it to be 3 decimal places, so that's great. I just want this upper deviation to be, I didn't look at what the number was, 5 thousandths, okay. So I'm gonna add 5 thousandths. This is just, yeah, I can't say why I can't get diameter in here. Did you guys add diameter to this? Yeah, that's a good question. Yours has the ability to do diameter? It's for the cylindricity, yeah. How I'm going to control that is by the diameter. Otherwise, this is kind of expressing surface. And so I was thinking, it's funny, I should have probably done this one ahead of time too. It's definitely A. I'm establishing A. Do I have to split this up? I'm not seeing anything super obvious. I'm not sure if it'll accept the diameter symbol in here. If I'm in here, of course, we don't have access to a little character map here. But diameter symbol on your keyboard is what, like a Alt 8960? I'm gonna try this. I don't think that it'll allow you to do that though. Allow a keyboard input there. Yours allowed your keyboard input? Oh, okay, let me try it again. This is feature priority. These are maybe no. It won't actually accept it. Yeah, that's interesting, huh? Another thing for me to check out a little bit. I can pull up my other model and see what I'm doing differently maybe on my other model. I think I have modeled this one, just not this year. Sorry, I messed up my deviation here. I at least want to enter.
Oh, you can't do this.
Can't do this at this time. Yeah, it's kind of making me. If I change this to straightness, it will allow me. That's interesting. For cylindricity, it doesn't seem like its default is to allow a diameter. It seems like it's like it wants to specify surface, which is the intuitive nature of Inventor and Houseman program. But sometimes I have to say, well, cylindricity is definitely my form control. I feel like I should have a diameter sign, but maybe not. Maybe this is an error on my other drawing that's like an
Google Gemini says it's the radial distance between two cylinders. So it's
oh
not a
yeah.
diameter,
So it's not
an
a
extension of a smaller or larger cylinder.
oh yeah, I got
So
you.
it comes out.
That makes sense, right?
Because it's not a diameter of 0.0.
It's actually
It would be a diameter
between its yes. Yeah.
distance from it.
Yes, I got you. That makes sense. So I do want it to be, what do I have on my thing? 10 thousandths? 10 thousandths. Oh, that's cool. Okay. So I'm gonna check on this and just check this off and say, okay, I think that I think that the way it's written on the drawing is not correct. I'm kind of interested, just bear with me for a minute. I'm gonna open up my other um the other one that I've drawn here. I didn't draw it this year, I drew it last year. I'm kind of interested in what the models. Oh, okay. Like on my actual drawing here. Like if you're looking here on my drawing. Oh, this one does. I have a different one on canvas though.
No, if you scroll, yeah, it's on canvas. Scroll further.
Hmm. Doesn't have it here. So I think this is technically more correct. And obviously so these have probably been applied at the drawing using the GD&T on the drawing, and it'll allow you to do it wrong, evidently. So that's interesting to me. That's one reason why I also like this model-based definition is because it walks me through these steps and it tries to prevent me from doing some error like I potentially have here. So that's interesting. And it makes sense because yeah, that makes sense, I guess. Yeah. And we haven't really talked too much about cylindricity, so it's just a whole nother form control that we'd have to sit there and like figure out how it controls, like you just looked up. That's great. So you'll probably see, yeah, I was gonna open up my part here real quick. Just for me to check what my old one was. I think I considered it exercise 4. Yeah, this is it. Let me open it. Back in the day, it was a little bit older. Even it has that going on. So I know that I didn't bring these model annotations in. Of course, I've changed these to be a little coarser tolerances than they were last year. But yeah, I can see it. It wasn't my model-based definition here does not match the drawing that I chose to draw for it after. So that's interesting to me. I've got some errors here between those two, which hopefully somebody caught and told me to revise at some point. or I caught them now when I went to reuse it. That's pretty common too. Maybe revisions don't get caught, but the second time you draw something, you're like, whoa, I'm surprised nobody caught that mistake. Now I'll fix it this time. Yeah. Okay, cool. So I'm going to keep this like this. I'm happy with that one. I just need to establish datum B now. I generally tend to trust Inventor beyond me in my interpretation for sure. So that's a planar surface on this one. It's a feature priority, not a feature of size yet. This is the surface perpendicular to datum A, establishing datum B, 10 thousandths, I think is what I put on that one. So I don't think I have to change anything here. So I'm just going to check that and apply it. Do one quick double check here though. Oh, technically it's 5 thousandths that I'm controlling that surface. So I might have to make just a small adjustment here, just to the tolerance. I'm going to double click in here and change this to 5 thousandths. A little stricter perpendicularity control here. Okay, 5 thousandths. And those are the two datums established. Now we can do a feature of size from those datums. So let's do another feature of size, this one. This I'm going to change to feature of size. There it is. It's calling it datum C, so I can change that. It's just pricking. It's just assuming that I'm going to establish maybe the rate, the axis of this hole as a datum C. I'm actually not controlling it that way. I don't think. Like I'm going to double check this, but on my print itself, I wasn't. I'm establishing. No, not. I'm not establishing that hole as a new datum. It's just from A and B. So I can drop. What I do is I just select it's mine is auto-populating that I'm choosing to have a datum identifier. I don't want to, I want to say none. I'm not establishing a new datum with this particular feature of size. But you could, I mean, that would be a, it would be a third datum, especially if maybe I have another feature of size pattern from this one. But I do need to make this as a deviation, right? So let me look at the specifics here. It's a deviation of 5 thousandths above only. 3 decimal place, 10 thousandths maximum material condition on a position. Okay. So I'll change this to be a deviation and can get as high as 5 thousandths. And this needs to be controlled. That, yes, 10 thousandths is great. Maximum material condition for the G, and then based off of A and B, yes. So check this out. Yeah, what do I have on here? Good point. Let me see. Do I have more than 3? Oh, I have an extra 0. Oh, okay. Let me go back and say, yes, I need to delete one of those. This one here. This one right here. How did it like this right here? You have A and B determined though.
I worried about like highways that are like nothing for